The American West stretches across landscapes so vast and varied that each region creates its own fingerprint on everything it touches. In Colorado, at elevations where the air grows thin and the seasons turn sharp, honeybees work against conditions that make their harvest something remarkable. The honey they produce here doesn't just taste different. It exists in quantities so limited that most people will never encounter it. Understanding why requires looking at what happens when insects bred for abundance meet an environment that offers everything except ease. Honeybees arrived in North America with European colonists, creatures shaped by millennia in temperate climates where summers stretched long and winters, while cold, followed predictable rhythms. These insects carry no innate knowledge of the Rockies. Their biology operates on assumptions written into their DNA over countless generations, assumptions about when flowers bloom, how long warmth persists, and what constitutes survivable cold. Colorado's high country violates many of those assumptions. Most commercial beekeeping in the United States happens at elevations below 4,000 feet, where temperatures moderate and growing seasons extend. Colorado's inhabited valleys and agricultural zones sit between 5,000 and 7,000 feet. Some apiaries operate even higher. At these elevations, the entire calculus of bee survival shifts. The colony life cycle that unfolds smoothly at lower altitudes compresses in mountain environments. Honeybees build their populations through spring and summer, reaching peak numbers when forage availability peaks. Workers live roughly 6 weeks during active season, their bodies wearing out from constant flight and labor. The colony maintains itself through continuous brood production, with the queen laying up to 2,000 eggs daily under ideal conditions. This biological engine requires fuel nectar converted to honey, pollen gathered and stored. In regions with long summers, colonies accumulate substantial reserves while maintaining large populations. Colorado's frost-free period in most inhabited areas spans perhaps 90 to 120 days. Flowers emerge late as snowmelt releases the ground. They vanish early when autumn cold returns. The window during which bees can gather resources contracts to a span that challenges their survival strategy. Scientists studying high-altitude beekeeping observe a persistent pattern. Colonies spend disproportionate energy simply maintaining themselves. Temperature regulation becomes paramount. Honeybees are cold-blooded individually, but achieve collective homeostasis. They cluster in cold weather, shivering muscles to generate heat, keeping the brood nest around 93 degrees Fahrenheit, regardless of external conditions. This process consumes honey. Winter nights that plunge below zero demand extraordinary fuel expenditure. A Colorado colony may burn through 20 to 40 pounds of honey merely surviving winter, depending on its size and the season's severity. That represents honey that cannot be harvested. But the challenge extends beyond winter survival. Spring buildup, that crucial phase when colonies expand populations to exploit upcoming blooms, arrives late and proceeds cautiously. Cold snaps in May or even early June can occur at elevation, forcing bees to cluster again, halting brood rearing, consuming stores. The queen's laying must synchronize with resource availability, yet weather creates false starts. Beekeepers call this the spring dwindle, a period when colonies may actually shrink as old winter bees die off faster than new ones emerge to replace them. A miscalculation means the colony never achieves sufficient forager numbers when the main nectar flow begins. Researchers have documented that high-elevation colonies frequently reach their population peak weeks later than lowland counterparts. By the time they're strong enough to gather substantial surplus, the alpine summer may already be waning. The flora itself presents complications. Colorado's ecosystems support diverse wildflowers, agricultural crops, and naturalized plants that bees visit readily. Alfalfa fields, clover patches, wildflower meadows in mountain parks all produce nectar, but bloom timing fragments across microclimates. A valley floor might bloom while slopes 500 feet higher remain snowbound. Forage appears in pulses rather than sustained flows. Honeybees excel at exploiting concentrated resources. They communicate via waggle dance, recruiting thousands of workers to rich patches. Mountain forage often means dispersed sources requiring more flight energy per unit of nectar collected. At elevation, thinner air reduces flight efficiency. Bees must work harder to achieve the same results. Studies indicate that bees at 8,000 feet show measurably reduced foraging range compared to sea-level colonies. Every flight costs more calories. Every flower visited must yield enough return to justify the metabolic expense. Water availability introduces another variable. Honeybees need substantial water for cooling hives during hot days and diluting honey for larval food. Colorado's arid climate, especially on the western slope and in southern valleys, means water sources can be scarce or distant. Foragers must dedicate flights to water collection rather than nectar gathering. Beekeepers in dry regions often provide water, but wild or less managed colonies face this constraint directly. The energy budget tilts further away from surplus production. Then comes the question of genetics and adaptation. Commercial beekeeping relies heavily on bee stocks bred for specific traits: gentleness, productivity, disease resistance. These breeds developed primarily in moderate climates. Italian bees, among the most popular, excel in long-season environments, but can struggle with resource management in short, intense seasons. They build large populations and may fail to reduce brood rearing quickly enough as fall approaches, entering winter with too many mouths and insufficient stores. Some beekeepers in Colorado have experimented with Russian or Carniolan genetics, lineages that show better cold tolerance and more conservative brood management. Yet even these adapted strains face limits. Natural selection over generations might produce bees truly optimized for high-altitude conditions, but commercial beekeeping involves constant introduction of new genetic material through purchased queens. Local adaptation remains incomplete. Disease and pest pressures compound these challenges. Varroa mites, parasitic arthropods that feed on bee hemolymph and vector viruses, infest colonies throughout North America. These mites reproduce in brood cells, and their populations explode when bees rear brood continuously. Shortened seasons might theoretically reduce mite buildup, but evidence suggests Colorado colonies still suffer significant mite pressure. A colony weakened by parasites enters winter compromised, more likely to fail before spring. Beekeepers must treat for mites, but treatments cost money and require labor. Each intervention represents overhead that makes operation less viable. When colonies produce minimal surplus, these costs weigh heavier. Economic realities shape what honey reaches markets. Beekeeping is labor-intensive. Equipment, protective gear, extraction machinery, bottling supplies all require capital. A commercial beekeeper needs hundreds of hives to generate livable income. In Colorado's challenging environment, maintaining that scale becomes difficult. Colonies require more intensive management, supplemental feeding, and frequent inspection. Loss rates run higher. Replacing dead colonies costs money. Many Colorado beekeepers operate small-scale, perhaps 10 to 50 hives, as sideline ventures rather than full livelihoods. Their honey production might total a few hundred pounds annually. Compare this to operations in California's Central Valley or Florida, where single apiaries with hundreds of hives each produce thousands of pounds per location. The volume difference is staggering. What honey Colorado colonies do produce often carries distinct characteristics. Nectar sources vary by region: clover and alfalfa in agricultural zones, wildflower mixes in mountain meadows, sometimes basswood or locust where those trees grow. The short, intense bloom periods can create honey with pronounced flavor profiles. Some beekeepers market this as premium product, emphasizing terroir and local character. Yet premium pricing cannot overcome scarcity. If the honey simply doesn't exist in quantity, it cannot enter widespread distribution. Most Colorado honey sells locally, through farmers markets, small shops, or direct from beekeepers. It rarely appears in large retail chains. Consumers outside the region may never see it, unaware it exists as a category. Climate patterns add variability. Drought years reduce floral resources. Colorado experienced severe drought conditions repeatedly over recent decades. Wildflowers fail to bloom abundantly. Agricultural irrigation becomes restricted. Bees find less to gather. In extreme years, beekeepers must feed colonies sugar syrup through summer just to keep them alive, producing no harvestable honey at all. Conversely, years with good snowpack and adequate moisture create brief abundance. But these cycles are unpredictable. A Beekeeper cannot reliably project income or plan expansion when production swings wildly year to year. Pollination services offer alternative revenue. Farmers growing crops like melons, apples, or pumpkins pay to have hives placed in fields during bloom. This income can exceed honey sales for commercial operators. Many Colorado beekeepers focus on pollination, treating honey as secondary. This shift in business model reduces the incentive to maximize honey production. Colonies managed primarily for pollination may be moved frequently, stressed by transport, and not positioned for optimal nectar gathering. The honey that might be produced remains incidental. Scientists continue studying how honeybees perform at altitude and in variable climates. Research examines genetic markers associated with cold tolerance, brood rearing patterns in short seasons, and optimal management strategies for mountain environments. Some findings suggest that reducing colony size expectations and focusing on quality over quantity yields better outcomes. Smaller, well-provisioned colonies may survive more reliably than large, resource-stressed ones. Other research explores forage enhancement, planting bee-friendly native species that bloom reliably despite weather fluctuations. These efforts contribute to understanding, but they cannot fundamentally alter the biological and environmental constraints. The broader context involves how regional conditions shape agricultural products everywhere. Wine grapes develop character from soil and climate. Coffee varies by elevation and rainfall. Honey is no different. It reflects the landscape and the conditions under which bees created it. Colorado's honey scarcity isn't failure. It's the natural outcome of an environment where survival itself demands most of what the bees can achieve. The honey that does emerge carries the signature of persistence against difficulty. It represents surplus wrested from a place that offers little margin for surplus. For those who keep bees in Colorado, the work involves constant negotiation with limits, checking hives in spring to find half dead despite careful preparation. Watching weather forecasts anxiously as late frosts threaten blooms. Calculating whether feeding sugar to save colonies makes economic sense. Harvesting modest amounts and knowing that this is simply what the land allows. There's no villain in this story, no problem to solve completely. It's ecology, biology, and geography in conversation, producing an outcome that feels almost intentional in its scarcity. The rarity of Colorado honey teaches something about abundance and constraint. Plenty exists in specific conditions. Remove those conditions, and what seemed simple becomes extraordinary. The bees work with the same dedication everywhere, but the results vary profoundly. High in the mountains, where summer is brief and winter is certain, honey becomes not a given, but a hard-won exception. Understanding that transforms how we see the jar on the shelf, not just as sweetness, but as evidence of survival and effort in a place that demands both.